Hello, Yawning Angel here with another AMOS video, and in this video I want to take you through a program which I have written which will extract the hexadecimal color codes from .abk and .iff files. But wait, have we not already covered this in a previous video? Well, yes we have. I've done a couple of programs which extract hexadecimal color codes from ABK files, so you can get the hexadecimal color values from any bobs which you have created. The first video I did on that wasn't too successful. The second one though worked okay because I'd corrected some of the mistakes in the program. But this program goes a step further, whereas it actually looks at .iff files as well. So why, Yawning Angel, you might ask, are you doing a third video and a third program covering this subject again? Well, let me tell you. My previous video where I created the 3D wall game, there should be a link up above here to that video. While I was doing that, I needed to get the hexadecimal color codes from an IFF file in order to set my default palette command within the AMOS program I was writing. I had no quick and easy way of doing this, so what I did, I took the original version of this program, which took the hexadecimal color codes from an ABK file and hacked it in order to get it to read an IFF file and extract the hexadecimal color codes from that. It was then I thought that this might be quite a useful program to release and get out there. Other people might find a use for it, who knows? So I've tidied up the code, made the program a bit more user-friendly, and I've got it to a state where it will read from .abk and .iff files, extracting the color codes and displaying them back to the screen, and also writing those values out to a file for future reference. So you might be wondering, Yawning Angel, are you not a glutton for punishment in doing a third incarnation of this program? Well, what I want to do on this video is take you through the functionality of this program, show you what it does, and I'll let you decide. Also, I want to note, this is not a video tutorial. This is purely to explain how this program works and how you might be able to get some use from it. Oh, also, don't forget, you're going to be able to download the source code for this program for free from my website. Details later on in the video. So with all that said, without further ado, you know how this works. Let's grab a cup of tea and dive on into the program. So some of you might be wondering, Yawning Angel, why do we actually need this program? Okay, well, those of you that have followed my videos will probably recollect we've done things with color palettes, when we've done things with screens, where we've put dual play fields on and the color palette's all gone a bit weird. Sometimes we've got a different color palette for our bobs and we need to tell AMOS to use those, and we need to actually set a default palette. We need to get those hexadecimal color codes in order to issue that palette or default palette command, because we need those hexadecimal color values to go into that command. So sometimes we just need to extract those codes. We need to know what they are, and we need to get them out of our bobs, we need to get them out of an IFF file. This utility program does just that, so I really do hope it's of some use. Right, here we are then, cup of tea in hand. Using the official Cave Dweller RMC mug today. This is the 2022 edition. 3 years old, who would have thought it? That is good tea this morning. Right, here we are then, inside the program. I'm not going to go through the program code. This is just an overview of how this program works. So when you run it, you're asked to enter the number of colors you wish to get the hexadecimal values for. 2 colors, 4 colors, 8, 16, 32, or 64. So I'm going to enter 32. And we're shown then these are the 32 colors which this program has. These are just default colors that it's got. This is my first set of 32 colors. So 0 to 31, obviously 32. We're told down here, this is the original palette, 32 colors, press a key to load a file. So now we've got our original set of colors. And now if I press a key, we now get a file request to pop up, and it gives us the option to load .abk or .iff files. So this is the filter that is built in here. So here's some files, here's some I made earlier. So here's a 32 color IFF file. So if I just select that, click OK, and now you'll notice here what it's done. It's brought back the hexadecimal color code values for this image which I have brought in. So it tells me down here colors from file, and it gives me the file name and asks me to press a key. Now you'll notice it shows the values. Some of them are a bit hard to read because it's been difficult to try and get alternating text color over the image. But don't worry, these values are dumped out to a text file at the end of the program, so you'll be able to see the text file for all the actual colors. Now down here it's telling me to press a key. So what does it want there? So let's press a key. Now this message window changes. It says T to toggle the color screens, E to exit. So and when I say E to exit, it doesn't mean it quits the program. It just takes you out of this viewing sort of section of the program where you can see the colors and the images. Watch this a minute. If I press T, so I've toggled back now. So this is the original color palette. So you see here, T, toggle, E, exit. It's showing this is the original palette. Press T again. So this is from my file, and it tells me here this is the file palette. I can toggle E for exit again, or F to actually see the file. Okay, so let's press F. Look at that. That is the image file that I've brought in, and that is a 32 color IFF file. That's a rather handsome looking fellow there, don't you think? So this is the image. So this is good. So it brings in the colors. It shows you what the color codes are, but then it actually gives you a representation of what that image is. Now, we've got a couple of limitations on this program, and let me explain them now. Some things you need to know about this program. One, we can only have up to a maximum of 64 colors across .iff and .abk files. We can only look at low resolution IFF images. I'm not supporting high resolution in this program because AMOS Pro will only give us 64 colors in low res mode. So I kind of went for this sort of lowest common denominator approach, figuring that's what maybe the majority of us are using. Also, the .abk files can only contain bobs and not sprites. I haven't done this for sprites yet. The code might work to a degree, but it's not going to be as functional for sprites. So I need to do a sprite specific section of the code, which I haven't done in this version. So all you're stuck with is .iff files and .abk files that contain bobs only. I may come around again at some point and do a version 4 of this program, but for now, this is all it does. Right, more tea. Kind of wolfing through this one this morning, might have to go get another one soon. Right, so this obviously is our image there. So we've got the whole T for toggle, E to exit. So if I press T, it takes me back, shows me the original palette, and I can keep toggling through this. This is my image color palette. That's the original palette, etc, etc. Right, so let's press E. Now the message down here changes and it says hex values to file, press a key. So what this is going to do now, it's going to take these values on the screen here and just dump them out to a text file. And it will dump that text file out into the same directory that your image file was sourced from. So if I press a key, there we go. So it's telling me, it's given it a name. So it actually appends this underscore HCV, hex color value, to the file name, the original file name, and just dumps it out. So it says file ya332 hcv.asc created in source file directory. And that is it. And the program ends. No frills, there's no menus. It's a very simple program. Basically, the program is, dive in, get the hex color values for your bobs or your IFF file, dump them out to a file, and get out. So let's go through this now and look at an ABK file with some bobs, and then we'll look at some variations, and we'll look at the text file that has been created. Actually, let's go and look at the text file first. Right, here we are. We're back in Workbench, and this is the file that was created. ya_free_32_ hcv.asc. So if I double click on that, you will see, here we go, text file with those hexadecimal values dumped out. No frills, it's literally just taken them 0 to 31, and it's dumped those values out. Yawning Angel, are these the correct values that you are showing us, or are you just making this up? Well, let's have a quick look. Let's look at my first three then. We've got 000, 877, CCB. So if I swap back to the program, bear with me while my Amiga catches up. Here we go. 00877 CCB. Yeah, looking good. The sixth color is FBB. 1, 2, 3, 4, 5, will be the 7th color. So yeah, FBB, we've got then 700 and 830 after that. Let's have a quick look. 700, that is 830, just make it out. Let's go to the bottom. We've got D77, 988 and 666. So let's go down there. D77, 988, 666, and we got 555, BAA, toggle back quickly, 555, BAA, yep, there we go. That's it. So that text file is working. So there we go. We've got a text file with our hexadecimal color values in for that 32 color IFF image. Right, now let's go and look at some bobs. You catch me mid-drink there. Right, so what I'm going to do is I'm just going to dive in. I'm going to pick a colour, 32. There's our 32 colours. Right, so now let's pick some bobs. So let me go into another folder. Yes, my Akira project folder. So something I keep circling around. That's a project for later. Right, so I'm going to choose this file, Akira bobs _3.abk, and load that in. So there's not a lot of colour change here, but you'll notice there's some difference here. So it's telling me here, colours from file, Akira bobs 3.abk, press a key. So now I can do the toggling. So this, so I press toggle. So this is my original palette. Just pay attention to this area around here, 4, 5, 6, and 7, or rather 3, 4, 5, and 6. So the differences are there. So that's my original palette. This is my file palette. Not a lot else has really changed. It's quite unadventurous in terms of color codes. So if I now get to this screen, I can now press F to see the file. And here we go. So there are 7 bobs here, and it's loaded all of those bobs in to give us a representation. Now this looks quite good, even if I say so myself, but if your bobs are larger and they're a bit more chunky, they will overlap. This is really just a case of dumping a visual representation of the bobs on the screen. It doesn't calculate how big the bob is and adjust the screen accordingly. It just dumps stuff out here, and I'll show you an example of it overlapping some stuff later on. It will also only give you 2 rows of bobs, and that's it. So if you've got any larger bobs or anything more than, what have we got, 7 there, so maybe we can get 10 slim ones in there, anything more than 20 or so bobs, you're not going to see them. So yeah, a little bit janky, but it gives you that rough representation of what the bobs look like. So now I can toggle back. There we go. Once again, I can press E to exit, hex values to file. It says here, yeah, bit of a text wrap issue there in that window. But once again, this is all about function rather than form. So that would have written those out to that file. Hex values as a text file, now written out to that directory. All good. Right, so if I run the program again, let's now look at, I'm going to do 32 colors again because it's a nice safe number. So let's go and look at a file where it might actually overlap those bobs. So now I need to navigate. So I need to go into my testing stuff folder. And I'm looking for, let's go down here, test ship to ABK. So if I load this in, so you notice the background color has changed, and this is because the color codes have changed. So don't be alarmed if the background, the background color, the screen color changes. It's because those colors are now different. They're addressed differently. So what was color 0 on your original screen is now a different color 0 on your second screen. Okay, so this has brought in those. So these are the colors for this this set of bobs. So press a key, so I have a toggle. So there's my original palette. So notice color 0 is actually black. Yeah, not brown as the text color, it's black. It's the background color, which is the actual color which that code relates to. And if I toggle, you'll notice the color 0 is CCC, which is this kind of grayish color. Yep, so you notice a difference there. Now, if I press F to see the file palette, so these are the bobs, and you'll notice that they're overlapping because, it's not calculating the size of them, it's just dumping them out one after the other. So, quite simple and straightforward. Original palette, file palette, view the file, E to exit, dumps those out, testship2.hcv.ase, create it in source file directory. And that is that. Just want to show you what happens for 8 8 colours and 64 colours, and a bit of an oddity. Right, so let's do 8 colours. So here we go, 8 colours. This is my original 8 colour palette there. Press a key, let's choose a file. So I've got an IFF file here, test image 1. This is only 8 colours. And here they are, and obviously the text thing hasn't quite worked out here. Don't worry, because it dumps it to a file. You'll be able to read those there. So press a key, and let's toggle original palette, file palette, and let's have a look at the file. There we are, very simple 8 colour image displayed there. Original colours, file palette, and E to exit, and it will dump those to those values, the HCV, hex color values, .asc will be created in the source directory again. Program ends. Right, so it's not all happy sailing, because there's some oddities on here that I just want to make you aware of. The program works okay. You know, we tell it how many colors we want to get for. We then load in our ABK or our IFF file accordingly. It displays that, dumps those values out to a file, everything's happy. So let's go 64, but I want to show you something odd. So there's a 64 color palette. So let's choose a file. Let's go into this one. So this image here, this is a 64 color version of that 32 color image I showed you earlier. Right, so we've got that. So if I now click OK, bang, there we go. Now we've got 64 colors. I can toggle, there's my original 64 colors. These are my new 64 colors. And now I want to see the file. What is going on there? What is going on there? Now I can tell you, this is AMOS being weird. It's the order of the colors as they've come in. All the colors are present. It has got all of those colors. So if I toggle back, these are all the colors that are involved. It's just the order of them. It's just been a bit janky. So what I will do, I'll show you this image in Personal Paint, just so you can see that it is actually a legitimate image. So let's do that now. So here we go then. This is the image in Personal Paint, 64 colors. Let's have a look. Image format, 320 by 200. It's a 64 color image. And it's loaded absolutely fine, and yet AMOS for some reason isn't happy with those colors, the way it lays them out. The order must be a bit janky, don't know what's going on there, but the image is sound, the color codes returned are correct, so you may have to do a little bit of playing around in terms of their order, but you know, are we really using 64 color images in our AMOS programs now? I don't know. Let me know in the comments down below. So in summing up then, what have we got here? We've got a program which will take the hexadecimal color values from Bob's in an ABK file or from a simple IFF image, extracts those color values and saves them out to a text file so you can reference them later. So you can then use those values in your own AMOS programs when you need to set your palette or default palette commands. You've got those hexadecimal values, you can just key them straight in. It makes life a lot easier, saves you having to do a lot of heavy lifting. This program's doing it for you. It's kind of okay. There'll probably be a version 4 at some point, but for now, I'm quite happy with this, and I hope you'll get some use from it and you'll find it useful. And that is it for this video. Thank you ever so much for watching. I really hope you've got something out of it. Don't forget, you can download the source code for this program for free from my website. There should be a link here, and there'll be a link in the video description down below. If you liked the video, give it a thumbs up, subscribe to my channel, all that good algorithm feeding stuff. I'd really appreciate it. Also, if you want to support my work, you can do so on Ko-fi. There's a link up here. Thanks again to the massive support I've been getting lately from all of you who have donated on my Ko-fi page. Thank you, one and all. I really, really do appreciate it. And I'm really humbled by the support as well. So thank you. Well, that's pretty much it for this video. More AMOS videos to come, of course. But in the meantime, whatever you do, look after yourselves and keep it retro.